Hello students, today we'll be looking at the topic electrolysis. We said that electrolysis is defined as the chemical decomposition of a compound into its component ion when a direct current is passed through the electrolytes. So you can simply say that electrolysis is the breakdown of a compound into its ion by electric current. That is the short form of the definition. So what that means is that, for example, we have sodium chloride. So you have sodium chloride, which is NaCl. So NaCl is our common salt, the one you use in your house. NaCl, that is a common salt. So once electric current is passed through it gives you Na plus Cl minus. Then you have aqueous, you have aqueous, yes. Okay, now another example, we have tetrazosulfate 6 acid, which is H2SO4 aqueous. Passage of electricity through it, or once electricity is passed through this, so we have 2H plus aqueous plus what? Plus what? SO4 2 minus aqueous, Cl minus aqueous. All these are ionization reactions. So once you ionize NaCl, it gives you Na plus Cl minus. Once you ionize H2SO4, it gives you 2H plus, and these are ionization reactions. They are like this. So now let me now look at some terms used in electrolysis. That is, terms used in electrolysis. Now, terms used in electrolysis. Number one, we have electrode. Okay, let me stop here. Now, the first one we have here is what is electrode. Now, what is electrode? We said that electrodes are metallic conductors in form of wire through which electric current enters and leaves the electrolyte. That is electrode. Then the second one here, we said that electrode is further classified into two, which is electrode. We have anode, we have what? Cathode. Now, what are these anode and what are these cathode? Anode are the positive electrode through which electric current enters the electrolyte. I repeat, anode is the positive electrode through which electric current enters the electrolyte, while cathode is the negative electrode through which electric current leaves the electrolyte. So we say that anode, they are positive, while cathode, they are the negative electrode. So we now look at the number 4, which is electrolyte. Electrolytes are substances in liquid form that conduct electricity and they decompose in the process. Electrolytes, they are further classified into 3. Here we have number 1, we have the strong electrolytes. So these are the 3 types of electrolytes. First one is strong electrolytes. We see that the strong electrolytes, they conduct electricity completely and they decompose in the process. Now, example of strong electrolytes, we have the HCl, which is hydrochloric acid. We have the HNO3, which is triazonitrate 5 acid, which is also called the nitric acid. Then we also have the tetrazosulfate 6 acid, and all alkalis group 1 base like potassium hydroxide, sodium hydroxide, and all of that, they are strong electrolytes. For weak electrolytes, we have ethanoic acid as weak electrolytes, and we also have water as weak electrolytes. Then we also say that weak electrolytes, they conduct electricity partially. Or incompletely. Then for the last one, which is non-electrolytes, they do not conduct electricity. An example is sugar, ether, and let's look at the practical aspect of this electrolysis, where we describe the electrolytic cell and also see how ions are being migrated from one electrode to another. Let's have it now. This is a simple diagram of electrolytic cell. So we have the electrolyte. Like I said earlier, that electrolyte is a solution that conducts electricity. So for example now, this is a beaker. This container serves as my beaker. Then I will dispense some salt here. I will do that right away. Then add some distilled water. Then place my, once I dispense some salt here, I add distilled water. Then that solution is already an electrolyte. So that is what is happening here. Let's assume we have sodium chloride here. Let me use mine. Let's say we have NaCl, aqueous. We have NaCl inside this place. That is sodium chloride. You dissolve it in water. That's why we are having the aqueous there. So once you do that in a beaker, we say that electrode is the what? Is anode, sorry. We say that the anode, okay, let me even finish it. This and this, they are electrode. Yes, because we said electrode are metals through which electric current enters or leaves the electrolyte. So these are the anode, these are the electrode, sorry. These two, they are both electrode. Among these two, one of them is cathode, the other one is anode. Then the negative electrode is the what? Is the cathode. While the positive electrode is the anode. They are both electrode. We now have positive and negative. Then looking at the electrolyte, this beaker that contains this salt solution is referred to as the electrolyte. This is the electrolyte. Then you see I cycled negative here because negative charges migrate towards the positive electrode, while positive charges migrate towards the negative electrode. Now, you know we have ions, where we have two types of ions. Let me say the positive ions and the negative ion. Where we call the positive ions the cations, then the negative ions are the anions. Now we have cations. Please don't mistake cations for cathode. Don't mistake cations for cathode. Cathode is not an ion. Cations, they are ions. Now, cations are the positive ions, while cathodes are negative electrode. Please take note of that. This is cathode, and it is what? The negative electrode. This is cations, they are positive ions. Then we now have the anions. Anions are the negative ions or charges. Let me still use that word. Charge. Positive charges and negative charges. Now, cations, okay, let me proceed with this. We have NaCl, we have to give you what? Na plus Cl minus. Okay, aqueous. Look at what I'm doing here. Now, this is Na plus. This sodium plus now this is a cation. This is a cation. This chlorine minus is what? An anion, because these are ions. Then what do you do now? This cation will migrate to what? This is plus. Plus will go to what? To negative, because we said that unlike charges, they attract. While like charges, they do what? They repel. So in this case now, cations are positive. They will migrate what? Positive will go to what? Cations are positive ion, and they will go to what? They will go to cathode, because cathode is negative. Okay, now for sodium, now we have cation for sodium. Look at sodium here. It is plus and it is cation. Come to the diagram. Look at plus. Look at where plus are located in the diagram. It is located at what? At the cathode side. Located at the cathode side. Then what about the anions? The anions are the negative, so they move towards the anode. Anode is positive. So the anions that are negative charge, they move towards the anode, which is the positive electrode. So you use wire to connect this, what you have here in this electrolyte, you connect it to a cell. A cell is a battery. We'll be making use of a DC, that is direct current. We'll be using battery here. Once you connect them, you will start seeing the movement of this ion inside the what? The electrolytes, of which I will be demonstrating right away. Now, this is my sodium chloride, NaCl. So, then you take some. Then you add some distilled water to it. My electrode. Here's my electrode. You can see my electrode. So the electrode is connected to ammeter so that I can detect when the current is on or off. So, but my ammeter is telling me positive and negative poles. So this is the electrode. These are electrodes. One will be negative, one will be positive. So let me see. The red here is positive. The red is positive, so this is positive, and this is going to be my what? This is my anode. So right here is my what? Is my cathode. So okay, then I have to connect to the source of energy. So this is my anode. So here will be my anode. Here will be my anode. So this is my cathode. So cathode. Then here's my. You can see the meter is reading. You can see it's reading. Can you see it? So can you see the bubbling of chlorine? Can you see it? But it is much on the anode, which is the positive. It is much there. You can see the bubbling is very. Okay, now let me quickly. So this is electrolysis of concentrated sodium chloride. Now, what happened here? The sodium chloride, that is the formula. Now, we look at it, we have NaCl aqueous, 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 aqueous. So, this one is your cation. This is your cation. Positive charge are cations. This one is what? Anion. So, this cation will migrate to cathode. Cation will migrate to what? To cathode. Anion will migrate to what? To anode. Now, during electrolysis, what you just experienced just now, during the electrolysis practical, you saw that there was more bubbles on the anode side, which is the positive electrode, than the bubble in the cathode side. So let's see what happens here. We now say at the cathode, what happened at the cathode? Both sodium ion and hydrogen ion, they both migrate to the what? To the cathode. Both sodium ion and hydrogen ion both migrate to the what? To the cathode. Among these two now, which one will be preferentially what? Discharged. So among these two, hydrogen will be preferentially what? Discharged. Hydrogen will be preferentially what? Discharged due to the position they both occupy in the electrochemical series. Sodium is at the top, while hydrogen is on the middle side. So, and the ones that are lower in the series, they can easily be what? Be discharged than the ones that are higher in the what? In the series. The ones that are higher in the series, they are the highly electropositive elements, while the one lower, they are less what? Electropositive. So, hydrogen is less. So, hydrogen will be preferentially what? Discharged. So, when hydrogen is, before I proceed, you see this cathode here. At the cathode here, at the cathode, we said that reduction reaction occur at the cathode. Then at the cathode, we have what? Reduction reaction. Reduction reaction occur at the cathode. From the definition, we have reduction reaction. Then we have oxidation reaction. Oxidation reaction. What is reduction? We say that gain of electron is reduction. Reduction is the gain of electron. Then we say gain of electron. While oxidation is the what? Loss of electron. Yes, you can use a oil rig. Oxidation is loss of electron. Why reduction is what? Reduction is what? Gain of what? Electron. Reduction is gain of electron. Why oxidation is what? Is loss of electron. Now, reduction occurs at the cathode. Why oxidation occurs at the what? At the anode. This one occurs at the cathode. Reduction occurs at the what? At the cathode. Why loss of electron, which is oxidation, occur at the what? At the what? At the anode. Because we have what we call electrolytic reaction. Electrolytic reaction from the word electrolyte, from the word electrolysis. So electrolytic reactions are redox reactions. Why? Because it involves the transfer. It involves the transfer of what? Of electron. I come again. Electrolytic reactions are redox reactions because they involve the transfer of what? Of electron. Do you understand that now? So let's quickly look at what happened here. We said that reduction occurs. This will give us what? H. Cathode. Cathode is the negative. Cathode is what? Is the negative electrode. So we want to know the gas that was involved here. So, because we already know that it's going to be hydrogen. Now let's have our equation. Hydrogen gas. This will give us this. Then hydrogen will combine in pairs inside the electrolyte to form hydrogen gas. Now hydrogen plus hydrogen is will now give us what? H2 gas. This one will now give you what? 2H plus 2E minus. We have to give you what? This is. We have to give you what? H2 gas. So the gas you saw at the cathode was actually what? Hydrogen what? Gas. And this is my what? This is my cathodic half cell. This is cathodic reaction. Yes, cathodic half cell reaction actually occurs at the cathode. So this is cathodic half cell. This is my half cell. Then for the anode, I'm going to get the reaction for the equation for the anode, which is anodic what? Half cell equation. Then you combine the two half cell equations together to get the overall what? Redox what? Equation. The word redox is two words. Redox reaction. Red, that is reduction. Os, which is the oxidation. So that is redox. So let me quickly have the second one. Now let's proceed. Let's have the anodic half cell reaction. The anode, we have chlorine and what? And hydroxide. Then when we have chlorine and hydroxide. Chlorine and hydroxide in their electrochemical series. Chlorine and hydroxide, they are close to each other, but hydroxide is the least there. Yes, is the least among their series. But chlorine is close. I don't really have time to. This is it. For this one, for this hydroxide, we have this. Okay, now this is the electrochemical series for the anions. for anions. Now look at chlorine here, look at hydroxide here, they are close. Since they are close, chlorine will now use the effect of concentration to be discharged in place of what? In place of hydroxide. Because of their distance. Had it been for this fluorine or sulfate, it will be far. This one will be preferentially discharged. But since they are close in the series, and this is what? Electrolysis of concentrated sodium hydroxide. So the effect of chlorine will make chlorine to be what? To be discharged. Then we now look at the anode. At the anode, so what do we have? Both Cl and OH minus, they both migrate towards the anode. I will say that oxidation occurs at the what? At the anode. Then, since chlorine is preferentially discharged, we have Cl minus. We have to give you what? Cl, because self oxidation is the gain of electron. This is minus, this is 0. So 0 is greater than 1. So it has been oxidized. So we have plus E minus to balance the ions. Just the way I did for this guy here. Now, looking at these two now, chlorine will also combine in pairs, just the way hydrogen combines with another hydrogen inside the electrolyte. We now have chlorine plus another chlorine. We now react to give you what? Cl2 plus E minus. Here, so we are going to have what? 2Cl minus. We have to give you what? Cl2 plus 2E minus. I've just balanced everything. Minus aqueous. This one will give us what? Gas. Now, this is the anodic half cell equation. This is the anodic half cell. While this one is our cathodic. What do we do now? Let's combine the anodic and the cathodic half cells. Let's combine them together to get the overall redox reaction. That during the practical, the gas that was released was what? At the anode, which is the positive electrode. It was actually chlorine gas. You can see it was intense, it was much, so it was massive. The gas, so it was. Then for this place also at the cathode, the gas you saw on the cathode side, it was actually what? Hydrogen gas, but it was not as much as the one you saw on the chlorine side. But let's combine the two equations to get our overall. So 2H plus 2E minus, we have to give you H2 gas. The second one is 2Cl minus, we have to give you Cl2 gas plus what? 2E minus. So the electrons are equal, so we cancel them out. So let's add now. We now have 2H plus aqueous plus 2Cl minus aqueous. We now give me H2 gas plus Cl2 gas. Now let's check if the work is correct. Hydrogen is 2 here. We have 2 hydrogen atoms here. We have 2 atoms here. 2, 2. Hydrogen is 2, 2. Then chlorine is 2. Chlorine is 2. So the ion is 2 times 1 here. This is 2. 2 minus times this 2. This is minus 2. Plus 2 minus 2, 0. Here is what? 0. So the equation is what? Is balanced. The equation is balanced. So if you are asked during the electrolysis of hydrochloric acid or sodium hydroxide or sulfuric acid, they will now ask you what is produced at the cathode and at the anode. So you have to quickly do the work I have done. Then this is where you will stop. If you don't want to get to this place, you stop here. This one, cathode, we got hydrogen gas produced at the cathode. On the other side, the anode, we got what? Chlorine gas was produced. Thank you for watching and remain blessed.